Hi there, and welcome back to Triplicate, and moving on still, while we've got the momentum rolling, moving on with the as yet unnamed radical synthesizer, and we're going to move on with the player interface today. So we have the turntable, a la hurdy-gurdy type arrangement for driving the note, and we have three strings from my old synth project for controlling the pitch of the note. And so today, well, last time we've got the magnetic rotation sensor working after we discovered that the magnet that came with the module was the wrong sort and weedy. So we have some more which are the right sort and stronger, so we're going to sort that, put that on and try that out. And we are also going to get this working. Now this board originally plugged onto a board with a pick on, which turned the position of your finger on there on the strings to a USB message. We are going to connect that to the Nucleo, so that is another job we're going to do here, and I think we are actually maybe going to start that and then we'll come back and finalize this at the end. So, slightly annoying, this thing is too big to go in the camera frame, the way I have the camera set up, but we'll manage, we'll persevere. So, because this PCB was designed on EasyPC, which I don't have on my laptop and I don't really want to install, though I do have a version, I did a bit of reverse engineering. So that is the connections relative to the strings, and yep, we've got our supply there. So the first thing we're going to do is try and power this up and see if we can get some outputs out of it, and somehow make some leads up to go onto these connectors. Okay, so the original circuit to that was done in EasyPC, which I don't have on my current computer, and I don't really want to install it, I could if desperate. So this is the circuit we have for it, written out on a piece of paper, which encouragingly claims to work off 3v3, so we shall see, but the op amps should, they're MCP 6004s. The op amps, and R9 and R10 are 18 and 36 ohms, and the string which goes down here is a few ohms, 10 maybe. So it does draw a bit of current, but you need to put a bit of current through a low resistance to get any sort of volts out, right? So the first thing we need to do is power it up, check it works, and find out how much current it's drawing, and whether the Nucleo is happy to supply that out of the 3v3 rail. Okay, so what's going on here? So current is flowing down through this resistor, down the wire here, which is this dashed line, through this resistor into ground. And A and B are two differential amplifiers. So A is measuring the difference in the voltage between the top of the wire and the bottom of the wire, and B is measuring the difference in the voltage between the finger in, i.e. where you press the wire onto the copper strip, and the bottom of the wire. And the sort of ratio of those two voltages is the position up the finger. And both these op amps actually have gain, because the voltage across the wire is not that big. So that's what's happening. So shall we see if it is happening on the actual board? Okay, so as usual, lash it with wires everywhere. So those are the power pins, and that's off the 10 mAh bench supply. So if I connect this, which goes to the multimeter, and what the multimeter way you might see it. So get some of this rubbish off the string. So that is connected to this piece of copper. So when I put this string down, I should get a voltage. Which I do, around a volt. Yippee! So if I move this up here, I get about 1.6 volts at the top, and slide it down to the bottom. Do that without, that's out of the camera view, isn't it? Slide it down to the bottom, I get about 200 millivolts. So that appears to be working, and I have off camera checked the string top values, and I've checked all three strings, and this guy would appear to be doing what it should do reasonably well. So now I need to get rid of all this jump lead mess and connect some wires that I can connect onto the Nucleo, and the current is 180 milliamps for the three strings. So I also looked at the data sheet for the voltage regulator on the Nucleo, and this is the Nucleo schematic, and this is the 3v3 voltage regulator, and it's an LD39050 BU33R, and if we look at the data sheet for that, come on, provides a guaranteed 500 milliamp output. Well, I don't think the Nucleo is drawing 320 milliamps, so I think we are good for using 500 milliamp, for using that regulator, i.e. the Nucleo, to power our strings. Okay, let's do some wiring. Okay, so I started thinking about wiring that to there and thought it's all a bit dodgy with this wire flopping about the place. It's all going to come off and get broken. So I decided, the usual thing, you decide to do a job, you need to go back and do another job before you can get to the start of the job you want to do, if that makes sense. So I have chopped a corner off the piece of board that this is on, and that bracket and the upside down cam, that bracket in there, held these two boards nicely together. I've also mounted this in this corner, so that's nice and secure, so those connections aren't going to get broken off. So all I need to do now is put some connections onto the bottom of these, mount that board there, and it's already got 4 holes when it was mounted on the pick board, and I can actually begin to do some wiring up. Whoopie-doos. Okay, so here she is, all wired up, and the board's secured down in just tie her up down to the board. This mess. It's a prototype and it looks like one. So next I've got to double check all the connections and no short circuits and stuff onto especially on the nucleo end, and then it'll be time to fire it up. Okay, so check the wiring and had to reverse engineer this because I don't have any software that I can look at the circuit anymore, and that is that. So that was fairly easy, and then had to work out which analog ports to put it onto on here without involving too much extra wiring up and plugs. And as you can see by the crossings out and scribblings on, that wasn't so easy. That took me a bit of working out. Okay, so right, let's see what it does. I have cracked on a bit, and so I'm not treating to a grand turn. It all turns on and the regulator on here powers these strings alright, which are off camera, I noticed. So let's see what it does in terms of software. So have set up all these analog channels in Cube MX. Just call them the default names because I'm only using analog for one thing. So in the analog ADC one, helpfully tells you which analog ports you can't use. So there we go, set all them up, and so these pretty much the defaults, and then you've got to set all these channel and sampling time, the other things with the analog inputs. And decided this time to use the DMA, so there you go. And the DMA settings, these come at half word. It's transferring 16 bits. So although the result register in the analog to digital to analog is 32 bits, it's actually transferring 16 bits. And it's an interesting thing to note because the little array, and you can see I had to experiment with it, the little array is declared at 16 bits. I've got 6 inputs and I have to cast that pointer, otherwise that function complains. Apart from that, we just say HAL ADC start DMA and off it goes. Hopefully it puts the results in that array. So should we try it? Okay, that's ready to start, but we won't start it yet, because we will start the monitor up. It turns out that the monitor code I wrote for the rotational, testing the rotation sensor, will work perfectly well with this, so I have modified it. Run. Okay, so that's ready to rock. Okay, so we've got the monitor window here, the PC program, and we've got the system workbench here, so we can drive it. So let's fire it up and see what happens. Right, well, the first
one is nothing, and then thereafter it's printing out the same number every time, which is crazy. There should be some jitter, so something isn't working properly. So if I pause it, so I looked at this for a bit and thought, well, hang on, we would expect to get 3 low values for the strings which have no input and 3 high values for the tops of the string, which is the whole length of the string. So it looks like it might be doing something vaguely sensible. Okay, so now let's start it with my finger on string number 1, and we should have reset it. So if we reset it again, yeah, we've reset it. Go. And let's just pause it so we don't get too many of them. And now we can see we've got the first one is still low, the second one is now high, the third one is high, the fourth one is high, the fifth one is low, and the sixth one is high. It's as though it's picking up the first value it reads and then not reading anymore. So we will just confirm this. We will now reset the code. We'll put a big finger on string number 2 and start it. Give that time to run a bit. Oh yeah, and now the first value is high and the second and fifth are low. So we just pause that, reset it, stick a finger on the third string just for completeness, and yeah, the fifth number is a middling value and the first and second are low. So it's working, but it's taking one set of readings and whoopsie daisy, it's not taking any more. Why? I've also put callback functions for the interrupts, but I've put callback functions for the analog to digital interrupt. Should they be for the DMA interrupt? So that's something I'm going to look at, but it certainly wasn't calling these functions because that's the flags value, which is all to 1 and 2, and the flags value FLG there is always 0. So onward and upward, I am going to do some head scratching and make a cup of coffee and see if I can find out why it's taking one reading and then somehow freezing up. Oh, I also notice the first reading is HAL status of 1. I shall check that out as well. Okay, so first mystery solved. I had in this sprintf call the ADC flags and the HAL status here the wrong way round. So it wasn't the HAL status that was 1, it was the ADC flags which was 1, which should be, which is telling me that the, I'll find it for you. There we go, the ADC complete conversion complete callback function has been called, so that's correct, and the HAL status is 0, which is correct. And as for the fact that it was taking one reading and then stopping, this was all afternoon's head scratching. Now I thought this HAL ADC start DMA function you would call it, it would take 6 readings and then shut itself down and be ready for the next time. Nope, it takes 6 readings and just sort of stops in active mode but not actually doing anything. So if you call it again, then it does nothing because it says it's already going. You have to call HAL ADC stop DMA function to stop it, which I've done after half a second, then waited another half second and gone round again. And that stops it, so you can restart it here and it will work. So let us have a look at it working. Okay, so let's start up the monitor. There we go. Let's start up the code, which is loaded up and ready to rock. First one always with zeros because that's the way it is. So look, that seems to be working because you can see the values jittering about a bit. So let us first string bottom and wind it up, so there, that's the second value. Seems to be working, and if we do this, yeah, we're essentially shorting out the string, so the top value should go down, which is the end there. Let's try the second string. There we go. Okay, that's working, and the top value of the second string is that one, that's working, and the third string it's on a bit slow because it's on a 1 second update. And the top value of the third string is there, so that is working. Yippee! And before we go any further, I think we are going to get this sorted. So we left it with that magnet glued on edge, because that magnet came with the rotation sensor, but that magnet is north on one face and south on the other, and we need a magnet that is north on one edge and south on the other, and we have a packet of them, no less. So let's try and chisel this magnet off here. So this is the old magnet, which, as I say, is wrong because it's north on one side face and south on the other, and dropped it. It's also pretty feeble, so this is a stainless steel ruler, but it's a bit magnetic. And I'm going to pull that off. Barely pulls the ruler at all, whereas this is the proper east-west one, which is east-west one. What am I doing? North-south. East-west one, north-south across, so it's actually not getting such a good grip on it, but that will all but pick the ruler up. So this wants to go on here like this, and I am going to stick it on with a piece of sticky tape because it's easier to get off. Easier to put on and easier to get off, and it's only got to hold the weight of a little magnet, and it's just this side of this hole. Okay, it is, there's the hole, and it is towards the dot, so it's towards me, just the side of this hole. No. Wiggle it, seems to be on firmly enough. And right now we have to fiddle the height of this thing. I think it will probably be too low, too high. Oh, whatever, shall we just try it? We'll just try it at that. Right, so we have the code back in rotation mode, the STM32 code. This is just test code. We will start again and write a proper project for actually outputting the proper data. So shall we send that to the STM32? We're ready to go, so if I hit that, this should start outputting. Oh, and it doesn't, so what have I done? Okay, debug time. Okay, just a little serial board gremlin test code. Let's not worry about it. Status 30, can't remember whether that's right or not. Should we? So, you see that? We're winding it gradually around. There we go, that looks good to me. Right. I think we'll call that a win for our new proper magnets. Right, well I think I'm gonna wrap this one up here. So we've got the hardware working, and we know we can generate software which will read the hardware in some way, shape or form. And this video has taken me ages for one reason and another. I thought I'd do the quick video with the tin whistle piece, which took me ages. Then we had another heat wave and we retreated to the boat for quite a while. It's a bit cooler and better to sleep, and then I got the good old COVID, which explains why the last bits of this video I'm a bit croaky and a bit less my usual cheery dynamic best. So on this we have yet to write the software to throw the numbers out so they can be used. There are the readings from the string and the turntable. But I think next time on this project we'll move back to our sound generation system and have another look at that. So I think that is it for this. So it's goodbye for now from Triplicates.
Goodbye.